Hello students, I hope all of you are fine and all of you are doing your studies well. Okay, so this is our video number part 11 where we are going to study, we are going to learn amines. Okay, so let's come to the board. So first of all, what are amines? So amines are the alkyl or aryl derivatives of ammonia. Okay, ammonia means NH3. Okay, ammonia means NH3. So whenever one or more hydrogens of ammonia are substituted by one or more than one alkyl or aryl groups, then these are called amines. Okay, so depending on the number of substitution, depending on the number of alkyl or aryl groups attached with the nitrogen, it can be classified into three types. One is primary amine, secondary amine and tertiary amine. So what is primary amine? When only one hydrogen is substituted by an alkyl or by an aryl group. So example, RNH2, okay, or ARNH2. So this is the example of primary amine because the nitrogen is attached with only one alkyl or aryl group. Next one, number 2. Whenever the nitrogen is attached with two alkyl groups or aryl groups. So this is the example of secondary. Okay, or on both sides there could be aryl groups or alkyl group as well as aryl group could be present also. Okay, so these all are secondary. And in case of tertiary, number 3, there will be three alkyl groups combined with the nitrogen atom, okay, or two aryl groups and one alkyl group can be attached with the nitrogen. So this will be called tertiary or 3-degree amine. So depending on the degree of substitution, that means the number of alkyl or aryl groups attached with the nitrogen of amine, these are classified into primary, secondary or tertiary amines. Clear this one? Okay. Now the next type of classification is depending on the type of substitution or depending on the type of group that is attached with the nitrogen atom of the amine. For example, one is aliphatic amine. One is aliphatic amine where there will be an aliphatic group just like CH3 attached with the amine. Okay, one or more could be attached. So these are the example of aliphatic amine. Now aromatic amine, there will be the presence of one or more benzene ring. So this is known as aniline or benzamine. So these different types of amines could be classified depending on the nature of the group that has been attached with the nitrogen. If it is an aliphatic group, then it will be known as aliphatic amine, and if the group is aromatic, that is like benzene ring, then it will be known as aromatic amine. Okay, and there could be a mixture of both an aliphatic group and an aromatic group. That means there could be the presence of, just like here, there is a benzene ring. Now in this side, in this part, there could be the presence of one CH3 also. Okay, So on this side there is a benzene ring and in this side there is a methyl group. So this type of example is called aromatic aliphatic amine, a mixture of both of the groups. Okay. So these are all the types of the amines that are found. Now next is the UPAC nomenclature. Just I am telling in a brief. Suppose there is CH3NH2. Okay. So in common name, you have to first write the name of the alkyl group, that is here methyl. So you have to write methyl and then amine. This is the common name. Okay. And when you are writing the UPAC name, then you have to write methane, as this type of compound is coming from methane, right? By replacing one hydrogen atom of methane with this NH2 group, we are getting this product. So that's why that will be, methane was the name of the starting compound. So methanamine, methane plus amine, that will be methanamine. Okay, methanamine. So by this one, this is the example of aliphatic compound. Now for benzene, okay, aromatic ring with a NH2 group, the name is aniline, common name, and here it will be aniline, can also be used as the UPAC name, or benzamine. Okay, so these are all the examples, and more examples you could see in the notes. Okay, so these all are examples, and make sure that all of you are writing your notes in time. Okay, I want to check all of your copies. I just have got only one copy to check in school, so make sure all of you are writing in time, and you have to submit also. Okay, so next we are going to discuss about the preparation of amines. Okay, preparation of amines. So from various products we could prepare the amine. So first we will see the example, that is from nitroalkanes, how we could prepare amines. So from nitroalkanes, not only alkanes, from aromatic nitro compounds also, just like from nitrobenzene also we will see here. So just like nitroalkane means CH3NO2. So we want to convert it into this compound, that is NH2, right? Initially it was CH3NO2 and we want to get this product from here, that is CH3NH2. So now just observe the difference between them. Initially there were the presence of oxygen, and after the reaction there could be the presence of hydrogen. So what could you understand from here? That means removal of oxygen and addition of hydrogen, right? Removal of oxygen and addition of hydrogen, which reminds us about the reduction reaction. As we know, in case of a reduction, there always happens the addition of hydrogen and the removal of oxygen. So we have to do reduction reaction here. So by which reagents we could reduce this compound? So for reducing we could use various reagents here. Number one is just like tin, Sn, in presence of HCl, okay, or iron in presence of HCl. So hydrochloric acid in presence of tin or in presence of iron, it could reduce this compound into a primary amine. another example of reagent, that is lithium aluminium hydride. That means the metal hydrides, by using this compound also we could reduce it. And the next one is hydrogen in presence of a catalyst like nickel or platinum or palladium charcoal. Okay, hydrogen in presence of nickel, platinum or palladium, charcoal is not needed, or palladium, by any types of metal, we could reduce the nitro compound into this amine compound. Clear? So this is a reduction method by which we could reduce the nitro compound into the amine compound. So the same process we can carry for nitrobenzene. Okay, for nitrobenzene we could use the same type of reducing agents, but for nitro compound the number 2 reagent, that only could not be used. Okay, so we could use the first reagent, that is tin HCl or iron HCl, or the number 3, that is hydrogen in presence of nickel, platinum or palladium. These two can be used for this case. So both of them give the result of aniline. Clear? So by this way we can convert or we can reduce the nitro compounds, nitroalkanes or aromatic nitro compounds into their respective amine compounds. I hope this is clear for you all. Okay, I'm removing this one. Now the next point, that is starting from cyanides and isocyanides. So number 2, starting from cyanides like CH3, CN, we want to convert it into CH2, NH2. Okay, writing it below. CH3, CH2, NH2. We want to get this compound starting from this compound. Okay, so again just observe here carefully that initially it was a carbon and a nitrogen, but after reduction there we could see the addition of hydrogen. So the addition of hydrogen always reminds us about the reduction reaction or the addition of hydrogen. Okay, so here again we have to use the reducing agents like again lithium aluminium hydride we could use here. Number 2, hydrogen in presence of nickel, platinum or palladium. Okay, this was the number 2. Now the third reagent that we could use here is sodium in presence of ethanol, C2H5OH. So these 3 reducing agents we could use here for converting the cyanide into an amine. Okay, so clearly it is a reduction reaction. Now observe carefully, what type of amine is this? This is an example of primary amine, because this nitrogen is attached only with one carbon. So it is a primary amine we are getting from cyanide. So cyanides after reduction they give primary amines. Clear? So now the same type of reaction we can carry for the aromatic cyanide also. Okay, now we are going with the same type of reaction with isocyanides. Okay, now see what will happen here. So isocyanide, that is CH3NC, methyl isocyanate. Okay, so what will be obtained as a product here? Now we will see. Okay, so the same type of reagents we have to use here, that is lithium aluminium hydride, or number 2 hydrogen in presence of any type of metal, or number 3 sodium in presence of ethanol. Okay, so here after reduction there will be again the addition of hydrogen, but in a little bit different way. So what will be formed here? Just see here in isocyanate the bonding looks like this: single bond nitrogen, double bond carbon. Okay, then carbon here is in the form of carbene. So now whenever there will be the addition of hydrogen, then one hydrogen will be added with the nitrogen, okay, NH, and as carbon generally shows tetravalency, okay, so therefore 3 hydrogens will be attached with the carbon, okay, fulfilling its tetravalent nature, and 1 hydrogen will be added with the nitrogen, fulfilling its trivalent nature. So they are now producing one amine which is secondary in nature. Just see here, this nitrogen is attached with 2 alkyl groups, 2 methyl groups on both sides. Therefore, it is a perfect example of secondary amine. So what we can conclude here? We can conclude that from cyanide we are getting primary amines, and from isocyanates we are getting secondary amines. Clear? So from this example we can distinguish or differentiate between cyanides and isocyanates. Cyanides after reduction give primary amines, and isocyanates after reduction give secondary amines. Clear this one? Okay. Now the next example is again one reduction reaction, but here we are using amide as the starting material, and here also we can produce 3 different types of amines: primary, secondary and tertiary. Okay, so just check it out. Number 3, starting from acetamide, CH3CO NH2. Okay, CH3CO NH2. So from here we want to get an primary amine. Okay, we want to get a primary amine. So now from acetamide we could get 2 types of amines. What will be they? One amine which will be having the same number of carbon just like the initial amide. How many carbons are there? 2 carbons, right? 2 carbons are there. So by using the acetamide we could get 2 products. One of them will be having the same number of carbon as of the initial compound, and one of them will be having the number of carbon 1 less than that of this initial. Okay, so one amine we will get here which will be having the same number of carbon, that is 2, and in the second round, in the second process we will be getting another type of amine where the number of carbon will be 1 less than this. That means 2 minus 1, there will be the presence of 1 carbon atom. So now how we could prepare this 2? So first of all, if we have to convert it into an amine which is having the same number of carbon, that means the product will look like this: CH3, CH2, NH2, right? So this oxygen should be removed out, and in place of this oxygen 2 hydrogens should come in. So that means there will be again a reduction reaction. So again we have to use the reducing agents for this reduction purpose. So we could use here lithium aluminium hydride, or we could use here sodium in presence of ethanol. Okay, lithium aluminum hydride or sodium in presence of ethanol. These two could be used here for reducing this compound into the primary amine. This is one compound. Now the second one, where we are getting the amine which is carrying one carbon less than that of the initial compound. So that will have the formula CH3NH2, which is carrying only one carbon, right? It is carrying two carbon just like this, and it is carrying one carbon less than this one, right? So this formula should be CH3NH2. So how we could get this product? This product can be obtained when this amide, it is treated with bromine or chlorine, in presence of alkaline solution, that means a base. Okay, in presence of an alkaline solution, that is a base like KOH. So this type of reaction is called Hofmann degradation. So this is called Hofmann, Hofmann degradation reaction. So why degradation? What is the meaning of degradation? Degradation means just this type of reaction is used in conversion processes for stepping down or for decreasing one carbon atom. Okay, if you want to get this type of amine, that's methylamine, okay, starting from a ethylamine, so then in that case, for decreasing one carbon atom, you could use this type of reaction. So this is called Hofmann degradation reaction, where acetamide has been reacted with bromine or chlorine in presence of KOH, so it will form methylamine. Okay, and in this process, by direct reduction, we are getting the amine compound which is having the same number of carbon atoms like this. Okay, so this was another step. Now this process, starting from this one, so the same process we could carry by using a substituted amide like this one, CH3CO NHCH3. That means one hydrogen of acetamide has been substituted with a methyl group, and after that we are carrying the same reducing reagents here for reduction purpose. So what will happen? Just only this oxygen will be converted into two hydrogen. So from here we are getting a 2 degree amine. This is a 2 degree amine, okay, and this was 1 degree amine. So what does it mean? So starting from this compound, okay, from acetamide or amide, simple amide, we are getting primary amine. But if we take substituted amides, where the hydrogens of the NH2 groups are substituted by an alkyl group, so then it could produce a 2 degree, or if both this hydrogen also, if both the hydrogens are substituted by two alkyl groups, then it could produce a 3 degree amine also. Okay, so this is our today's class. So in our next class we will see another reactions of this, another types of preparation methods for this amines. Okay, I hope that all of you have understood today's class. Okay, so we will meet in our next class. Thank you and have a nice day.